Welcome to Mathletes. I'm Gori, and today we'll be tackling networks and finding the minimum spanning tree. We'll be looking at every exam question ever asked in HSC Standard 1 over the last 5 years. So grab a pen and let's get started.
Okay, let's get started with networks, and in this lesson we'll be looking at minimum spanning trees. All right, so the first question says, the network shows the distances in kilometers along a series of roads that connect towns. What is the value of the largest weighted edge included in the minimum spanning tree for this network? Okay, so in other words, we need to find what the minimum spanning tree looks like before we can answer this question of what is the largest weighted edge. So first thing we do is we put our dots down for our network, our vertices, they're also called. There we go. That's all of our dots. All right. And then for our minimum spanning tree, we always want to start with the smallest number. So that would be 4 in this case. Next smallest number is 5. And we keep going until we've connected all of the dots, but just once. So 5 is our next biggest number, then 6. All right. And now we've only got one more dot to connect. We could choose either the 9 or the 10, but because this is a minimum spanning tree, we want to choose the smallest number. So that's 9. That's it, we're done. This is what our minimum spanning tree looks like. And so now to answer the question, what is the value of the largest weighted edge included in the minimum spanning tree? That would be the number 9. Therefore, our answer is C. Let's take a look at the answers. So the answer is 6C. All right, question 14. The time in minutes it takes to travel by road between 6 towns is recorded and shown in the network diagram below. In this network, the shortest path corresponds to the minimum travel time. What is the minimum travel time between towns A and F, and what is the corresponding path? Okay, so to get from A, which is here, to F, we don't have much of a choice. We have to go via B, C, and D. That's our only choice. And then we do have a choice once we're at D. So we could choose to go up via E to get to F, or we could choose to go via DF, right? And it wants us to minimize the travel time. So the question is, if we go via E, it's going to take us 5 minutes plus 8 minutes, which is equal to 13 minutes. And 13 is a smaller number than 14. So we're going to choose to go up and around this way. So therefore, the path that we're going to take, it's going to be A, B, C, D, E, F. And the minimum travel time is just adding all of these numbers together. So we've already got our 13. We're going to add 10, 20, and 15 to it, which is just these numbers here, 10, 20, and 15. So we get 3 plus 5 is 8, 23 plus 2 is 5. So we get 58. And don't forget the units, which is minutes. All right, next question. New roads are built to connect a town G to towns A and D. The table gives the times it takes to travel by the new roads. Add the new roads and times to the network diagram below. Great. So to get from A to G, it takes us 8 minutes. And to get from G to D, it takes 22 minutes. Explain whether the path in A is still the shortest path from A to F after the new roads are added. Okay, so we saw in the previous part of the question, it took 58 minutes and we went via BCD. But in this case, we have a different option. We can go this way instead. And the question is really, Is it faster to go via AGD, which is 8 plus 22 minutes, so 30 minutes? Is that going to be faster than going via ABCD, which will take us 15 plus 20 plus 10? So this way is going to take us 45 minutes. And so, yes, 30 is the smallest number. And so we'll say no, the new shortest path from A to F is now via A, G, D, E, F. Great. That's it. Yep, we got our minimum travel time of 58 minutes, A, B, C, D, E, F. And yes, it's not the shortest path anymore. A, G, D, E, F is the shortest path. All right, the question says, the diagram shows a network with weighted edges. Draw a minimum spanning tree for this network and determine its weight. Great, so we want to start with the smallest numbers on the network. So we're going to start by connecting B to F with 1, G to H with 1, and then we go on to the number 2. So with 2, we can connect E to A. And now we have a choice. We could connect B to C or F to C. Either one works. Let's pick B to C. And we've connected that with the number 2. All right, moving on to 3. We can connect F to G with a 3. And we can also connect H to I with a 3. All right, and now moving on to the number 4, we can connect H to J with a 4. And A to B with a 4. And then lastly, D to J with a 4. And that's it, we're done. We only want to connect all of the dots once, and that's our minimum spanning tree. So now we can just add up these numbers and we should be able to get to the answer. I'm just going to do that on my calculator. So it's 2 plus 4 plus 2 plus 1 plus 3 plus 1 plus 4 plus 4 plus 3. And that gives us an answer of 24. All right. Part B says, is it possible to find another spanning tree with the same weight? Give a reason for your answer. So yes, it is possible to have another minimum spanning tree with FC connected instead of BC. As we said earlier, that was a choice we made. These two connections have the exact same weight. And that's it. So let's take a look at the answer. And yes, our weight is 24. And yes, use BC instead of FC, and the weight is the same. Moving on. Question 18. A network of running tracks connects the points A, B, C, D, E, F, G, H, as shown. The number on each edge represents the time in minutes that a typical runner should take to run along each track. Which path could a typical runner take to run from point A to point D in the shortest time? Okay, so that's point A and that's point D. And to get there, first we're going to choose um, the most efficient path, which is the most direct path. And, just following this line, AF, F to G, and then on to D. Let's see what that adds up to. So 5 plus 5 plus 5, it's going to be 15. All right. So that's a good answer, but I think we might be able to find a faster way to get there. So as you can see here, instead of going directly from A to F, I could instead choose to go via B. So AB and then F. And if I go this way, it's going to take 3 plus 1, which is 4, and that's smaller than 5. So we want to choose the minimum path, the shortest path, and therefore that's definitely going to be quicker than the first path that we picked. So let's see if are there any other ways that we could optimize this path. No, 11's bigger, 9 is bigger than 5. So there's no way of avoiding this next 5. It's the smallest number between F and G. And then once you're at G, again, it's the smallest path to get from G to D. So this is our answer. Which path could the runner take? They're going to go A, B, F, G, D. And perhaps it wants us to tell them what the shortest path is going to be, and that's going to be 3 plus 1 plus 5 plus 5 is 10. So that's going to be 14 minutes. Just because it's worth 2 marks, we want to give them the time it takes as well as the path. Okay, a spanning tree of the network above is shown. Is it a minimum spanning tree? Give a reason for your answer. Okay, so we need to find what the minimum spanning tree is for this network. So let's go ahead and put our dots in first. So A, B, C. Then we have F, we have H. Just going to write the names here. A, B, C, F, H. E's down here. We have G and D. All right, so let's go ahead and start with the smallest numbers that are available. So that would be the number 1, and that's going from B to F. So we put that one in first. I don't see any more number 1s, so we'll carry on to number 2, and that's connecting H to F. No other 2s on the network, so then we move on to 3, and that's connecting A and B. All right, moving on to the number 4, that's connecting F to E. No other 4s on network, so we're going to go with the 5s, and that's connecting F to G, and then G to D. Oop. And then lastly, we've got C to connect. We can ignore all of these other numbers like the 6, the 7, the 9s. We just want to connect the C to the rest of the network. And the shortest one there is going to be the number 9 right here, C of D. That's it, we're done. And now we can compare our minimum spanning tree to the one that they've given, and we can see immediately it looks different. That 11 shouldn't be there, it should be CD like this. So let's answer the question, is it a minimum spanning tree? No. Give a reason for your answer. CD should be connected instead of BC, as it is 9 instead of 11. Okay, that should do it. Yep, so our answer here was ABFGD, correct, and it's not a minimum spanning tree. BC is not the shortest path to join C to the tree. That's it. The table below shows the distances in kilometers between a number of towns. Using the vertices given, draw a weighted network diagram to represent the information shown in the table. All right, so let's go ahead and fill it in. So the town S is connected to the town Y via 280. All right, I'm just going to strike them out when I add them. S and B are connected via 275. Okay. C and Y are connected via 60. Okay, C and B are connected 150. Okay, and then Y and S, we've already got that for 280. Y and C, 60, we've already got that. Okay, Y and M, 530. All right. And then B and S, 275. B and S, 275, already got that. C and B, 150. Yep, already got that. Y and M, 530. Got it. B and M, 790. So B and M, 790. Yep, and this is B and M again. All right, so we're done. A tourist wishes to visit each town. Draw the minimum spanning tree, which will allow for this, and determine its length. Okay, great. So we want to start with the smallest number, and on this, it would be 60. So let's start with connecting Y and C for 60. Our next biggest number is 150. So 150. And then our next biggest number would be 275, connecting S and B. And then our last vertice is M. And we have two choices. We could go for YM for 530, or we could go for BM for 790. And we're going to pick the smallest number, which is 530. And that's it, we're done. So then the length of the minimum spanning tree is just adding these numbers, 530 plus 150 plus 60 plus 275. All right. Let's just do this by hand. So 8 plus 6 is 14, plus 7 is 21, 5 plus 4 is 9, and 1 is 10. So our length is 10, 15. And we want to put the units in as well. So it's 10, 15 kilometers. That's it. 10, 15 kilometers. And yeah, that's what our diagram looked like as well. All right, question 17. The network diagram shows the travel times in minutes along roads connecting a number of different towns. Draw a minimum spanning tree for this network and determine its length. Okay, so we start off by putting our dots on the map. So Q, K, M, U, W, P, C, and F. All right, so to create our minimum spanning tree, we start by putting in the lines that have the shortest length. So that's going to be 10, then 15. Then our next biggest number is 20, connecting W and F, 20. And then we have 20 here, connecting U to M. And then we have 25, connecting K to M. And then we have 30, connecting Q to K. Okay, and now with C, we have three options. We could use 45, we could use 40 or 45. We want to pick the smallest number, so that's 40. And that's it. We're done. We have connected all of the dots, and that's how we know that we have completed our minimum spanning tree. So now we simply want to add up these numbers. So 30 plus 20 plus 25 plus 10 plus 15 plus 40 plus 60. Sorry, plus 20. Okay, so I'm just going to do this by hand. So we have 4 plus 2 is 6, plus 4 is 10. And then 3 plus 2 is 5, so that's 15. And one more is 16. So 160 is the length of our minimum spanning tree. And how long does it take to travel from Queenstown to Underwood using the fastest route? Okay, so first we can take a look at our minimum spanning tree, and that's going to give us QKMU. So QKMU, and that's going to be 30 plus 25 plus 20, and that is 5. And then 3 plus 4 is, yep, 75. So that is one way that we could do it, right? So QKNU. But there's a little trick here because the minimum spanning tree, it doesn't necessarily give you the fastest route between 2 points. So can you see there's actually a quicker way to go that is smaller than 75? So we want to look at this diagram at the top, and we can find a quicker route to get there. And so the answer is, instead of going via Kingsville, instead of that, what we can do is we can actually go like this, and then that route is going to be 45 plus 20. So 5, 4 plus 2 is 6. 65 is smaller than 75. So therefore, this initial answer was incorrect. We want to say that the shortest route is QMU, and it takes 65 minutes. Let's check our answers. Yep, we got 160 and 65. And that's it. Thank you so much.